So what we're going to do is start off by, before we get into solving by square roots, I want to talk a little bit about number types, specifically radical numbers, and do a little bit of an introduction to imaginary numbers. We'll see more of those at chapter 11, but I want you to have that tool available while we go through this stuff with solving by square roots. I want to start with the most basic idea. What are numbers? They're things that count. Yeah. That the most basic answer to numbers are they're what we invented to count. So, for example, if you're someone who has sheep, so there's some sheep. I need numbers to keep track of how many sheep I got, right?
They look like stormy clouds.
Whatever, they're sheep. Here. Sheep. There. So I come up with a number system to deal with this. So in this case, I come up with the number 3. Or at the time, we also would write it as 3. Now, as a guy who takes care of sheep, I'm pretty much limited to dealing with whole numbers of sheep, aren't I?
His name's Farmer Jack.
Farmer Jack? Okay, Farmer Jack. Still see a few of those around.
It's Hiller's now, dude.
Is it?
Okay, so there's my sheep. I don't have 3 sheep anymore. I've got, let's see. Hey, stop hopping away. 7 sheep now?
Yeah.
All right, and so I need a way of writing that. And Roman numeral for 7 would be V for 5 plus 2 more, right?
Oh, that's how you do it?
Yes, that's how you do Roman numerals.
Oh my god, I never knew.
And as a guy with the sheep, that's all I need. Or I could also write in Arabic numbers. I could write out the number 7. And that's how many sheep I have.
So then how do you do 8?
How would I do 8?
Yeah.
All right, 8 sheep. Well, first I add a sheep to my herd. So I'll buy a sheep from Ian. There's my 8th sheep. Boom, now I have V, 3 is 8. And if I add a 9th sheep, so there's my 9th sheep. He was a 2-for-1 deal. Instead of writing it that way, I write it as, it's 1 before 10. So it's 10, but 1 before 10. Or 9. You don't need to know how to do Roman numerals, but there's a reason I'm using Roman numerals here. The big one is, if I had 10 sheep, do I need an actual number for 0? Because if I don't have any sheep, I don't say I have 0 number of sheep. I say I have no sheep. Which means I never have to worry about zeros. And it wasn't until a while later that we got into the Arabic number system that said, hey, if I have 10 sheep, so there's my 10th sheep, and he has spots, or some kind of virus, whatever.
That looks like bacteria.
Yeah.
That sheep has 5 legs.
It has a very sad tail. Yeah, it's a mutant sheep. There we go. So I would write the Roman numeral 10, which is an X, or in Arabic numbers, I would write 1, 0. So I've started now dealing with place values. And that's a difference between Roman numerals and Arabic numbers. They've provided place values. So as we've developed more needs with numbers, we've invented better number systems. We shifted from Roman numerals, which are good for counting. In fact, you'll notice like on a movie, it'll always say copyright, and they'll have a whole bunch of letters there. Those letters are the count up of what year it is when the movie's copyrighted. It still works for that. And they're terrible with arithmetic. Do I have to worry about half of sheep? If I'm going to sell Ian some of my sheep, am I going to sell him half a sheep?
No, we could cut off the fur and give that for him.
Yeah, I can shear it, but that's not selling him half a sheep, that's selling him the wool. I could cut the sheep in half, literally, but then I don't really have a sheep anymore. I have a half a sheep worth of meat.
Carcass.
Yeah. Fractions, though, come up if I sell things I can sell in parts. Like when I go from only keeping track of what's in my herd to keeping track of fabric, I have to develop fractions. I know we all love fractions, right?
No.
So we invent fractions.
Actually, I like fractions.
Yeah.
They're fun.
And fractions are usually defined as take a whole thing and cut it into parts. And let's say I want to talk about I'm going to sell somebody those 3 things. That's 3 out of 6, right?
Or 1/2.
Or 1/2. So I have invented fractions to deal with parts of things. I'm still dealing with things I can count, though, right? You can look at this whole piece of pita. I've cut it into 6 pieces. I've handed somebody 3 out of the 6 pieces of pita, and therefore they have half of my pita loaf.
Pita loaf.
Pita loaf, sure,
Pita loaf.
pita.
The loaf of the pita.
I'm going to stay over in the Greek-Roman area, the Mediterranean. Guys, we also invented negative numbers later on down the road to deal with going into debt or dealing with numbers on a number line. As we're inventing numbers, let's talk about this thing. What's the square root of 9?
3.
3?
Mhm.
How do you figure it's 3?
3 times 3 equals 9.
Okay, because 3 squared equals 9, right?
Yeah.
We've all seen this before?
Yeah.
Okay, good. That's actually half the answer. What's the other answer?
9.
Nope.
Oh wait, tell me -3 to the -3 squared
Because -3 times -3,
could be a positive, which
It's
could
still
be
a positive 9.
9.
Good job, Marion.
Thank
Yeah.
you.
the concept of the, yeah, go ahead.
I'm smart. You're jealous.
9 times 1?
MG.
The thing about square roots, the square root symbol, is it's what number times itself. Or specifically, that number squared. So what times itself would give me 9?
3.
In that case, 3. I can also talk about the square root of, let's take 64.
8.
That's a positive -8. Now notice 2 answers. Because -8 squared is 64, as is a positive 8 squared. Remember when we started talking about quadratics, we said there's going to be 2 answers to every problem? This is where that comes in. We also had to invent a set of numbers called irrational numbers.
Math will be a lot simpler if we just stuck with
Because, again, as I'm doing things and developing numbers and saying, hey, I want to count this, I want to add this, I want to figure out what this is. Oh, I don't have a number for that yet. Let's go back for a second. I said I'm going to take my pita and cut it up into pieces. How much am I going to give to Miriam? Well, if I only have whole numbers like when I count my sheep, I can't talk about giving her 3/6 of the piece. I can only say, well, here are 3 pieces. But the idea of a half, I need to invent the fraction. Oops. Irrational numbers are what happens when I take the square root of a number that doesn't have neat, perfect squares.
Oh yeah.
There is no neat answer to square root of 3, is there?
No.
No, it's a decimal. If I take my handy-dandy calculator here and say, tell me what the square root of 3 is, it kicks out 1.7320508, and then this is going to continue without pattern. Or repetition. There's nothing pretty that follows that. So we call that an irrational number because I can't break it down as a fraction. And by the way, guys, you do want to have this down. I'm going to get you for this vocab later this week. So I'm going to ask you, what are square roots? What are irrational numbers? What are fractions? What are counting numbers? Hi. Probably on Friday.
Are you serious?
As is it on prom night.
Your cereal.
I am not cereal.
Okay, what will it be on? I'm gonna study this time.
It's gonna have this.
Do we have a quiz every week for the rest of the year?
I want to do at least one quiz a week for the rest of the year. Can we get back to work?
No, 3.
Now,
Okay, hold on, let me copy all this.
I know me too.
I need it for
Guys.
sources.
Guys. So, guys, irrational numbers are the numbers that we invented to deal with square roots that are not neat. Like the square root of 3. The square root of 2 is another one that it actually started this. If I take a square, which is up over there, and I make the sides 1 and 1, the diagonal is the square root of 2, which is not a rational number. So they could make squares, and they go to measure that, and they can never get a neat fraction out of it. So they said, oh, crud. We'll call that an irrational number. There's one more kind of number we got to talk about today.
Don't you know?
Okay, I'll pause here. I'll keep babbling, then we'll let you guys copy and not you know that matters.
Thank you.
Actually, I'm going to rewrite the word irrational over here because in the video it's going to be behind my portrait. Irrational.
Irrational numbers are numbers without pattern, like.
The decimal continues without pattern.
Okay.
And they're generally square roots that are not perfect squares. So square root of 2, 3, 5, 6, 7, 8, 10. Square root of 4, well, we know that one. The square root of 9, we know that one. Square root of 25.
It's 5.
Yeah.
Yeah.
Those ones are neat ones. Jason?
Remove that.
If you have to. Okay. So irrational numbers are these decimals that continue indefinitely. I want to write one more thing about them down. Word about irrationals. So again, irrational numbers. If I ask for an exact answer, and I actually spell it correctly, exact, that's something like the square root of 10. If I ask for an approximate, that is, let's see, 10, take the square root, 3.16. It's a rounded decimal. If any problem asks for exact answers and it involves square roots, you leave your answer with a square root in it. Now, this is where things get tricky. I'm going to take a quick pause here and get myself an extra slide because I'm going to need one more slide after this. And we'll get back in there. Boom. There we go. Imaginary numbers. So far, these are all real. These are real numbers. I can measure that distance. Even radicals. I can measure off the square root of 3. I can measure off the square root of 2. I can especially with Pythagorean theorem stuff. Let's deal with imaginary numbers, though. These are numbers that we invented because somebody said, what happens when I'm going to put that over where it's not going to bump into me for sure. What's going to happen when I take the square root of a negative 25? Now, I went with the calculator. It's like, oh, yeah, I got that. Watch. I'll just take my calculator, and I'll type in, let's see, 25. I'll make it negative, and I'll push the square root button. And I get E. Once the calculator kicks out an E at me. And then maybe if I'm really into it, I'll put my hand and go, my calculator's broken, or something like that. What number times itself will give me a negative 25? Nothing. I might try a negative 5 squared, but that's a positive 25, isn't it? I know it's not 5 squared. That's a positive 25 for sure. But they're still not negative. So we had to invent a system of numbers called the imaginary numbers. Imaginary numbers basically say, go ahead, take that square root of a negative and slap an I on it.
An I? Where did that come from? I don't think this is kindergarten or alphabetical.
No, that's legit. What that I represents, this I denotes an imaginary number. Indicates, says it's there, shows an imaginary number. Now, when we do chapter 11, we'll talk more about how I works. I does kind of some neat things as far as the math goes. But for our purposes today, that's how we deal with when we get stuck trying to take the square root of a negative. We simply do it as though it was positive, and we attach the letter I to say, yeah, but remember, this isn't a real answer. It's an imaginary answer because you can't, in the real world, take the square root of a negative number.
You can't?
Well, what two numbers times themselves would give me a negative 25?
Oh.
Nothing.
Nothing.
But I can tell you, as a preview of coming attractions, you can square 5i, and you'll get negative 25.